Welcome to this second webcast in the DIDCOMM Superstack video series. This is a demonstration of Prototype1, which is the simplest example, simplest instance of creating a DIDCOMM agent. And so here we've got a Visual Studio project called VCTPS Prototype1, and it's really got two files in it. One is the DIDCOMM Agent TSL, or Trinity Specification Language file. That's where we're going to define our agent. We're going to define the protocols that our agent supports. We're going to define the message types supported by that protocol. And then the structures that are used to define the messages themselves. And then we'll simply rebuild that, and it'll build an implementation of our server for us. And then in this program.cs file, we'll show a simple example of how we create an instance of our agent and start it up, and then we're going to send an empty message to it. Just as an example of the world's simplest DIDCOMM server and how easy it can be to build them. So let's look at the TSL file, and we're starting at the bottom, work bottom up. So we have a server defined. The server is a DIDCOMM agent, and that's going to be used to create the base name for our DIDCOMM agent implementation. And it supports one protocol. It could support multiple protocol, but this one just supports one. It's called DIDCOMM endpoint. And the DIDCOMM endpoint is defined to be an HTTP endpoint. And it's a request response protocol. It understands a DIDCOMM message request, and it returns a DIDCOMM response. And we continue on our upwards journey here. The response is easy. We're just going to return an integer value, a return code, if you will. When we look at a DIDCOMM message, we can see that the DIDCOMM message is like we'd hope. It's a DIDCOMM encrypted message. And so it has a single element of that type. Well, what does a DIDCOMM encrypted message look like? Well, it looks like this. When you look at what comes back out of the intrinsic DIDCOMM pack and unpack methods used for encrypting and decrypting DIDCOMM messages, it has these four properties. And so in this particular Prototype1, we're just going to send an empty message, so we won't be using these properties, but we'll use them in Prototype2 when we actually create or use a simple predefined structured credential and send that as a JSON payload that will then be deserialized into this encrypted message. Also in Prototype2, we'll show the ability to use Trinity storage. So if you want to take an existing structure, such as an encrypted message, and persist it, serialize it, and persist it into the Trinity in-memory database, you simply define a structure and put the prefix cell in front of it. And all that really does is add a long integer field to the beginning of your structure. And so we're going to use that also in Prototype2 to show that once we receive this encrypted message, we're going to create an instance of a cell and we're going to persist it into local storage. But for now, for Prototype1, let's just take the world's simplest example of basically sending a null message, an empty message, to the server that we've defined below here. So let's go into program.cs. I'm just going to go in here and hide this to make it a little more simple. And we'll go up to the top here. And if you remember, Our server was defined to be, server name was defined to be DIDCOMM Agent. And so when we click build, this file is read. We can see the different C# files being created at the bottom here. And when we go in, we end up with something called DIDCOMM Agent, the name of our server definition, and the word base after it. So that's wrapping our implementation. And so we're going to create our local derivation of that abstract base class. And we can see that it's got a DIDCOMM endpoint handler. Again, DIDCOMM endpoint being the name of our protocol. So part of the automatic code generation is it will create a handler for every protocol that we define. And if you remember, our protocol is defined as having a DIDCOMM message request and a DIDCOMM response as a reply. And so we can see that our handler accepts or expects a DIDCOMM message and returns a DIDCOMM response. Here we're setting the response to be just an integer return code, value 0. And that's all there is to it. And this, you don't even have to remember how to code that, because if you just start by creating an implementation definition of your class, you can go up in here and just say create an abstract class, and it's interrogated. It's done retroflection, if you will, on the base class, and figured out that there's a DIDCOMM handler, and here's the message types, all from our TSL. So let's go and put our original implementation back in there. And where this to do is, this is where when we start to send a proper DIDCOMM message, encrypted message, this is where we'll be receiving it. So if we go down here into the program, we're going to override the HTTP port to be 8081. For no particular reason, we're going to create an instance of our agent implementation described above. We're going to start that agent. We'll see a bunch on the console log. We'll see a bunch of messages come out as that happens. Finally, we'll see, DIDCOMM agent being started. We're just going to send an empty message for now. And so when we look in here, we're going to create an instance of our HTTP client. And we're going to post it to localhost 8081. And then the name of the endpoint is the name of our protocol. Remember the name of our protocol here, which corresponds to the name of our handler up above. Here. So very simple architecture, very easy to understand. So then the next step is we're going to create a post message. HTTP post. Our payload is just going to be our empty string. This is where we'll be doing some change up in Prototype 2. We're going to send that. We're going to get the result, and then we're going to print out the result, the JSON response. The JSON response, of course, is just going to be whatever the return code is that we set it to. So let's put a breakpoint here. We're going to catch ourselves here at the bottom, and then finally, as we exit, we're going to just stop our agent, and so we'll see that in the trace log as well. So let's run this. It always takes a second to start up. And we're going to see our agent being started. We can see that it's listening on 8081. We can see that DIDCOMM agent started message coming out of our little driver. We can see the HTTP put request, and there's the URL, the trace code that's in program.cs. We can see that we're sending the null payload, and we've broken here in the middle of our handler. And if we look here at our request, we can see that we have an encrypted message, but it actually has a null payload. So we're going to set the response, or DIDCOMM response return code. That's the return code here. And let this continue on. So the response came back 0, and we can press enter to stop our DIDCOMM agent. So let's just look at where we are here. So we output the URL, we output our empty payload, and then when we sent the put request with our empty payload, and we got the 0 response back. So this is a fully functioning DIDCOMM agent. It doesn't do very much, but it's a fully functioning DIDCOMM agent. So please look ahead and look at Prototype 2. This is where we put some meat on the bones, so to speak. We'll create an actual or use a dummy structured credential, and we'll encrypt that using the intrinsic DIDCOMM libraries, and then we'll send that as an encrypted message. And so up here in our handler, we'll see some code in here that will actually receive that and decrypt it, and using all the proper keys. We're going to have to set up a little key vault, just an in-memory data structure to keep track of, Alice and Bob's keys and that sort of thing. So look forward to seeing you in the next video in the series.